test. I, in fact, don't have all of them graded. I still have some copies that I need to grade from the online. But I wanted to quickly go through some of these. I'll post all of the keys on Blackboard so you can check how whether I graded your paper correctly or not. There were 3 versions, A, B, and C. They're very similar. I just shuffled around some answers and numbers. I also want everybody to check on Blackboard to make sure your grade has been recorded and recorded correctly. You know, when I get too much drinks in me, I get all dizzy. No, I'm kidding. Yeah, I said, if they get this one wrong, I'm gonna drink. I said, oh man, that looks right. No, I'm kidding again. But it is hard to take care of this many papers accurately. So please check to make sure every single time I've recorded your grade correctly. Of course, if I recorded incorrectly in your favor, then just shut the heck up. Okay, so the first one was just memorization. I can't help you if you can't memorize. So you just fill out the chart. I did try to grade subsequent parts by looking at how you filled out the chart so that you weren't penalized for missing the same thing more than once. So I did look here to make sure you got everything correctly. Now, on this test, you were told that in number 2, the 2 angles were complementary. On some of them, we said supplementary on the other 2 versions. But if the 2 angles are complementary, you add them together to 90. If they're supplementary, you add them together to 180. And then you solve for X. Please try to show your work. I can't give partial credit if you don't show your work. And in fact, I'm going to stop giving any credit if you don't show your work. So please show something. So I said on this particular problem, I'm going to add the 2 angles together to get 90. And then it's just a little algebra problem. And I got X is 16. For the next one, if you're converting from degrees, minutes to seconds into decimals, well, to convert to a decimal, you take the part and divide by the whole. So you divide if you're going to decimals. Okay, which row are you in? You would think I could put them in order here, but that counting thing that gets me. There's the last row. 14 is the last row.
Oh, sorry.
So don't try to stump me with row 15. Oh, were you sitting in that little room behind the camera, behind the wall there? So if you're going the other way, if you're given things as a decimal and want to convert to minutes and seconds, then you've got to multiply by the decimal part. So we want to see what fraction of the 60 the 0.12 is. So I took 0.12 and multiplied it with 60. Well, 6 times 12 is 72, and then I tack the 0 on it, and then you move the decimal over twice, so it gives me 7.2. The 7's the whole number of minutes. So right now I've got 71 degrees, 7 minutes. Now I convert the 0.2 into seconds by, again, multiplying by 60. 2 times 6 is 12, tack on the 0, and then move the decimal once. So that gives us the 12. So the correct answer was 71 degrees, 7 minutes, 12 seconds. On this one, we did a similar triangles deal. We've got, most all of you got this, but probably a good idea to go in terms of feet. If you draw a water tower here with a 36-foot long shadow there, 12-inch ruler would be a 1-foot item, and 3 inches is 3/12 or 1/4 of a foot shadow. And so the proportions we can set up is that T is to 1 as 1/4 is to 36. So T is to 1 as, 36 is to 1/4. So to divide by a fraction, you just flip and multiply. So all you had to do is multiply the 36 times 4. And that gives you the 144. Let's see, determine which are not defined. So I wanted to find out what you knew about the quadrantial angles. So in this problem, the 0 degrees is the positive x-axis, and the 180 degrees is the negative x-axis. on the x-axis, the y-coordinate is 0. So if any of these had a y in their denominators, then this would be undefined. So I'm looking for r divided by y or x divided by y at 0 and 180. R divided by y is the cosecant, x divided by y is the cotangent. So do I have any of those here? There's a cotangent of 0, so that's got a y on the bottom. But my cosecant is not at 180, so that one's going to be okay. So that one's defined. 270 degrees is the negative y-axis. So there is a y value on that. So that one's defined. Secant is r over x at 180 degrees. X is a value, so it's defined. But tangent was y over x at 90 degrees. The x coordinate is 0. So that one's not defined. So A and C were not defined on number 5. Now for the reference angle, a reference angle is a positive acute angle formed with the terminal side of the stated angle and the nearest x-axis. So I drew an angle of, well, I didn't draw it. I first took out one lap around the unit circle and got me to negative 100. So that tells me that I'm back in here at negative 100. The nearest x-axis is at negative 180. So the reference angle is the angle formed between those two. And that gave me the 80 degrees. In the following problem, we've got parallel lines cut by a transversal, and I've labeled the alternate interior angles. When parallel lines are cut by a transversal, the alternate interior angles are congruent. So I set the two algebraic expressions equal to one another and solved for x. And that gave me x is 5 in this example. Then y is related to this given angle here in that it's vertical. And vertical angles are also congruent. So I know y had to be the value of 130 plus 2x when x was replaced by 5. So the 130 plus 2 times 5 gave me the 140. One of the underlying themes of this class and of life in general is that if you know the value of one trig function, you know the value of all 6 of them. So that problem appeared on this exam many, many times. Here I gave you the value of the cosine, I'm sorry, the sine. I gave you a hint to what quadrant it's in. Here I gave you sine as a positive number, so that tells me I'm in quadrant 1 or 2. But the next statement says that tangent is a negative number. So I know I'm not in quadrant 2. I'm not in quadrant 1, I'm in quadrant 2. So I drew a triangle in quadrant 2 that has the sine of the angle. The angle in trig is always formed with the nearest x-axis. So there's the angle theta. The sine is the opposite over the hypotenuse. And I want to find the cosine. So I need to find the adjacent side. And I did the Pythagorean theorem, leg squared plus leg squared is hypotenuse squared. And I found that the other side, the adjacent side, is the square root of 5, but x is going back in the negative direction. So it's a negative square root of 5. And that makes cosine the adjacent over the hypotenuse. Okay, so half of the problem was getting the correct quadrant and sine, and the other half was getting the correct ratio. Questions so far? Okay, then I'm back. On back, we're comparing sine of 40 degrees with the sine of 50 degrees. The sine is related to the y value. It's y divided by r. So if we fix r to be a set length, I want to know, does the y value get larger or smaller as I make the angle larger? So one way to keep track of that is just to put a circle here so that the circle has a fixed radius. And so if I compare a 40-degree angle, let's just randomly draw a 40-degree angle and a 50-degree angle, I want to see which one of those two has the larger y value. So if I can find my red pen, I'll draw a y value here. Here's the y value for the 40-degree angle. And here's the y value for the 50-degree angle. So the second line that I drew is longer. That makes the sine a bigger number. So y divided by r is bigger for the sine function as the angle gets larger. For cosine, it goes the other way because cosine compares the x's. So if I were comparing the cosine of 50 with the cosine of 40, the one with the smaller angle measure has the larger x value. In part B, I'm looking to find the cosine of a positive angle compared to the same angle but negative. So if you think of where a negative 20-degree angle is, it's in the fourth quadrant, and it has the same reference angle as the one in the first quadrant. I also know that in quadrant 4, cosine is positive. Same reference angle, same sign, that means they have to be equal. So that's why there's an equal sign here. This other one was our cofunction identity. You had to recognize that these two angles are 90 degrees apart from one another. So if the sine takes on a particular value at angle theta, the cosine takes on the same value at angle 90 minus theta. So 90 minus 52 was the 38. That's what makes these two equal. Then the fourth one, I'm checking to see if you know the quadrants, again, the signs. So you had to recognize that 250 degrees is in quadrant 3. And in quadrant 3, with our all students take calculus, quadrant 3 tangent is positive. And so that says the tangent is bigger than 0. This was the problem where we had to find the sides of a right triangle again. So I plot the point 8, -6 over 8 down 6. And then I form the angle with the nearest x-axis. So the -6 drops me down into quadrant 4. I did the Pythagorean theorem, leg squared plus leg squared is hypotenuse squared. 8 squared is 64, 6 squared is 36, so they add to 100. Square root of 100 is 10. And then I use the ratios to find the trig functions. The sine is opposite over hypotenuse, so that's the -6 over 10. Cosine is adjacent over hypotenuse, 8 over 10. Tangent is opposite over adjacent, -6 over 8. Flip those numbers over to get cosecant, secant, and cotangent. Okay, so let's do number 11 on paper, because again, this is highly important that you know the values of these. So let me do them on paper. I want to find the sine. So this is problem number 11 from test 1A. I want to find the sine of 960 degrees. So I can see that I've gone more than one lap around the unit circle. Lower the paper. I can see, you can't see. There it is. So I'm going to start taking out 360s as much as I can. So 960 minus 360 leaves me 600. So take out another 360 and it leaves me 240 degrees. So I recognize that 240 degrees is in quadrant 3. Quadrant 3 between 180 and 270. So I'm in quadrant 3, so here I go. I know I've got to have a minus. Then the reference angle for an angle of measure 240 degrees. I find the distance between that and the nearest x-axis. 240 minus 180 is 60. So I take the sine of 60 degrees. So then I go back, I find the sine of 60 degrees. Come on, blurry. Sine of 60 degrees is the square root of 3 over 2. That's right here. And so I put that in here with the minus. Okay, so when you're doing this stuff, I need to see your thought process and not just jump from here to here. Because if you jump from here to here incorrectly and I see no thought process, I think, well, they're grabbing numbers out of the air. So show me what you're thinking. Well, not all of your thoughts. The next one is the cotangent of 315 degrees. All right, does anybody know what quadrant 315 degrees is in? It's in quadrant 4. Do you know if the cotangent is a positive number or a negative number in quadrant 4? It is negative because only cosine and secant are positive there. So now I'm looking for the cotangent of the reference angle. So I'm looking to find the distance between the 315 degree angle and the 360 degrees. So I subtract and I get 45 degrees. I know at 45 degrees, the x and the y are the same. And cotangent is x divided by y, or the sine and the cosine are the same. So I know that this value has to be a 1. Quadrant 4 makes it a -1. The next one in part C is the tangent of -180 degrees. So that's a quadrilateral angle. That's the negative x-axis if I went back this way. An example of a point on the negative x-axis would be x is -1, y is 0. And tangent is going to be the y divided by the x. So it's y is 0, x is -1, so that means tangent at -180 degrees is going to be 0. In part D, we have the cosecant of -570. So again, that number is bigger than 360. I'm going to add a 360 to it. And I get a -210. So I know the quadrant that's in, -210 is a little bit bigger than -180. So that puts me here in quadrant 2. And my reference angle then is the distance between the -210 and the -180. So that's just a 30-degree angle that separates those two. So I need to find the cosecant of 30 degrees and then decide whether it's a positive number or a negative number. In quadrant 2, is the cosecant positive or negative? It's positive because the cosecant is 1 over the sine. Sine is positive in quadrant 2, so I know it's positive. It's 1 over the sine of that number, so it's 1 over the sine of 30 degrees. I can go back to my chart and get the sine of 30 degrees. The sine of 30 degrees is right there, it's 1/2. So 1 over 1/2 flips the half over and gives me a +2 as the cosecant of -570 degrees. Then the last one is the cosine of 420 degrees. So again, we do our subtracting thing. And it puts me coterminal with a 60-degree angle in quadrant 1. I know in quadrant 1, every trig function is positive. I also know that the cosine of 60 is the same as the sine of 30 because of my cofunction identities. So it should be a +1/2. Okay. All right, then in number 12, we wanted to do things backwards. In number 12, I give you that the tangent is a positive number. In fact, it's a +1. And I want to know all places 1 lap in the unit circle or 1 lap around the circle where that can happen. I know tangent is positive in quadrant 1 and in quadrant 4. So I need the quadrant 1 angle and the quadrant 3. Quadrant 1 and 3. Tangent is 1 when x and y are the same, or where cosine and sine are the same. And that's at 45 degrees. So 45 degrees is my quadrant 1 angle. It's also my reference angle. If I want to find the measure of an angle in quadrant 3 that has 45 degrees as a reference angle, I just add that to 180 degrees. So in quadrant 3, my angle is going to be 180 plus 45. And that's 225 degrees. Yes.
Yours something different on this. I have that same test.
Oh, well, maybe
But 315.
because the other test had that as an answer. So scratch it out and put 225. The 315 is the answer to number 13. Number 13 asks for a bearing. So here's number 13. Plot the point -3, 3. -3, 3. And we want to know the bearing that gets us here. And we had two ways of writing bearings. The first way was just from a north line, the angle formed in the clockwise direction to get to that ray. So the first way is this way. And the second way is to use the northbound ray and go in that direction. So I just have to figure out what on earth has the property that the X and the Y have the same coordinate? What angle? 45 degrees. So if I use the second method, then I've gone from a north line 45 degrees in the west direction. If I use the first way, I've gone all the way around a whole circle except that 45 degrees. So the second way is 360 minus 45. And that's the 315. So there's two types of bearings, the one from a north line, and there's the one from either a north or a south line with an acute angle in between. So I took either one of those. Then on number 14, I drew the second story window. Up here is the vertical leg. The dog is in the yard, so I drew that as a horizontal leg. But here's the key. The angle of depression is not this angle inside the triangle. Angles of depression are measured from the horizontal. So that was the 60-degree angle. But that gives us a 30-degree angle here. And I can find X using the ratio of the opposite side to the adjacent. So that's what I said. The tangent of that 30-degree angle is X over 20. I multiply by 20. Many of you stopped here, but I want you to tell me that the tangent of 30 degrees is 1 over the square root of 3, because it's sine of 30 degrees divided by the cosine of 30 degrees. And so if you simplify that, then 20 over square root of 3 feet is the correct answer there. The next one, I'm going to draw this because I wanted to see the bearings. I didn't want you to just start using right triangle trigonometry on the next one without showing me that you have a right triangle. So if you just did the Pythagorean theorem without even showing me the correct bearings, I didn't give you full credit because some of you were using that on an obtuse triangle. So I wanted to see the correct drawing. So we're told that a ship travels 20 miles on a bearing of 30 degrees. So that's from a north line. So from a north line, draw a 30-degree angle. And 20 miles. So let's make this 10 miles. And there's the other 10 miles. So there's 20 miles there. Then they change the bearing from that point. So you got to draw another north line. And the bearing changes to 120 degrees. So that's 90 degrees plus another 30. So 90 would take me to here. Plus another 30 takes me to about here. So that's 120 degrees. And then they travel for 30 miles. So that's 10, 20, 30. And then we want to find the distance between the two right here. So this was a 20, this was a 30. The next thing I wanted you to do is tell me why this is a right angle. If you didn't tell me why it's a right angle, I couldn't give you full credit for this. So what I'm looking at here are parallel lines cut by a transversal. Parallel lines are cut by a transversal. The interior angles on the same side of the transversal are supplementary. So that tells me this angle right here is 150 degrees. That leaves this much to complete the 360. So if I take 150 plus 120, that's 270 degrees. That means the remaining angle has to be a 90-degree angle. That's what I needed to see, that you had a right triangle. So if I wrote on your paper, where's the right angle? That's what I was looking for. You're convincing me that that was a right angle because of some mathematical reasoning, not just it felt good to you. Then once you have the right angle there, that makes X the hypotenuse and 20 and 30 the lengths of the legs. So after we have the right angle there, then we can say that 20 squared plus 30 squared is X squared. So 400 plus 900 is X squared. That gives me that X is 1,300 miles. It's all good? Any questions from you guys at home? Okay, our next test is October 19th. That's a Tuesday. The next test is in class for everybody. So those of you guys taking the test, if you feel like you can't be in class for this next one, please make arrangements with the testing center to take it there, because it's so hard for me to download all these things that are your tests, and not just download them, grade them. So make sure that you make arrangements for in class. If you can't be in class, make arrangements with the testing center in West Hall. Some of you walked in later. Would you like your tests back? Come up here and I'll give you your test, or if you want several tests, I'll let you take all of them. Get your test by 9/3. Remember what row you were in? I've got them kind of separated by rows. 13, 14, 12, 9, there's 10. 10, there's 10. Oh. Anybody else? You're not gonna take all these back with me? Yes, but you got yours though, right? Yeah. Thank you. All right, so what do you know about geometry? Shapes. Well, our favorite shape is a circle, right? A circle is a perfect shape because it's perfectly symmetric, right? So in a circle, if I want to find the circumference of a circle, I need to know this radius of the circle. So suppose I have a circle whose radius is 10 inches. Does anybody know the circumference of a circle whose radius is 10 inches? Don't give me decimals.
pi times 3 pi.
What's the formula for the circumference of a circle? 2 pi r. R was 10, so 2 pi times 10 is 20 pi, right? What we're going to do today is take a circle and cut it up into pieces where the pieces will correspond to our degree measures of 30 degrees, 45 degrees, 60 degrees, and so on. So I'm going to start with this statement here. So page 2, we're in section 3.1. We're going to learn about radian measure. So we can measure angles in degrees. And we can even break that down into minutes and seconds, but we can pretty much measure angles in degrees, minutes, and seconds. And in something called radians. A radian is an angle defined by an arc length. An arc length is part of that whole circumference. A circle of radius r contains 2 pi r radians. We will consider a circle of radius 1. And that one will be called the unit circle. Unit standing for the 1. The equation of the unit circle, circle centered at the origin of radius 1, is x squared plus y squared is equal to 1. So in this particular circle, if the radius is 1, the entire circumference is 2 pi radians. In degrees, we can make an angle that goes all the way around the circle with 360 degrees. So this says that 2 pi radians corresponds to 360 degrees. Our circumference of this circle of radius 1 is 2 pi times 1, so 2 pi radians. I happen to have such a circle right here. Everybody got one? 2 or 3? How big is pi? About 3.14-ish. Let's just, so 2 pi is somewhere in the neighborhood of 6, right? There are 6 radians all the way around the circle, 6-ish, right? 2 pi. There are 360 degrees. 1 degree is found by taking the circle and cutting it into 360 equal pieces. So imagine that circle that I just gave you as a pizza, and you have 360 friends who all want the same size piece. You've got to make a 1 degree cut to get everybody the same size piece. Now, a radian is not the same size as a degree. 2 pi radians is 360 degrees. So if I take that sentence and divide by 2, then pi radians is equal to 180 degrees. So in our unit circle, let me find me one, I can tell you the degree measures and the radian measures of the quadrantial angles, the ones that correspond to the positive and negative x-axis, the positive and negative y-axis. So let's start there. I have to back up a bit on this. So what I'm going to do in the blanks that are here, I'm going to list the degrees in the blank that has the little degree symbol and the radians next to it. So both of them start with an angle of measure 0. 0 degrees is the same as 0 radians. The ray has not rotated. But if I go all the way around the circle to 360 degrees, then 360 degrees corresponds to 2 pi radians. So if you also want to put a 360 here, you could put a 2 pi here. So if there's 2 pi radians all the way around the circle, then halfway around that 180 degrees corresponds to pi radians. So here's the 180 degrees, and here's the pi radians. Since this is the unit circle, the intercepts with the axes are all by a ray 1 unit long. So the ordered pair right here corresponds to x is 1 and y is 0. If I go back here to 180 degrees, then my ordered pair is x is -1, y is 0. When our ray is flush with the x-axis, the x-coordinate corresponds to the cosine of that angle, and the y-coordinate corresponds to the sine of that angle, because x and r are the same and y and r are the same. So this says that the cosine of 2 pi radians is 1, and the sine of 2 pi radians is 0. Back here, this says that the cosine of pi radians is -1, and the sine of pi radians is 0. If the top half of the circle represents a ray traveling pi radians, then what about a quarter of the circle? What does the 90-degree line of the positive y-axis correspond to in radian measure? Half of a pi, right? Pi over 2. So up here at 90 degrees, the angle measure in radians is pi over 2. So let's count our quarter circles. My ray that rotates from here to here has gone 1 pi over 2. From here to here is 2 pi over 2, which makes the negative y-axis correspond to 3 pi over 2. So the 270-degree angle corresponds to 3 pi over 2. Now the ordered pairs on the positive and negative y-axis have x is 0, and up here y is +1, down here y is -1. So the ordered pair up here is 0, 1, and down at the bottom, it is 0, -1. Again, on the quadrantial angles, the y and the r take the same length. The y over r was the sine, and the x over r was the cosine. On the y-axis, the x is 0. So that says cosine of pi halves radians is 0. The sine of pi halves radians is 1. And down here, the cosine of 3 pi halves radians is 0. The sine of 3 pi halves radians is -1. Now, how many degrees are there halfway between the 0 and the 90? So this diagonal line halfway between the 0 and 90 degrees is the 45-degree mark. The radian measure will be half of pi halves. Take pi halves and multiply it by a half, and what do you get? Pi over 4. So 45 degrees corresponds to an angle of measure pi over 4. So let's count by degrees. This arc was 45 degrees. The next one is 45 plus 40 to give me 90. The next one, the solid line through here, 90 plus 45 is 135 degrees. Add another 45 degrees to that, and you're down here at the 180. 180 plus 45 puts us here at 225 degrees. Add 45 to 225, and it puts us down here at 270. 270 plus 45 degrees is 315 degrees. So I'm just adding 45s. Now let's add pi fourths. So all of the solid lines here are quarters of the parts. So that's 1 pi fourth, 2 pi fourths, which simplifies to pi halves. That makes this one over here 3 pi fourths. Add another pi fourths, puts us at 4 pi fourths. That corresponds to pi. Down here then would be 5 pi fourths. Add another pi fourths gives us 6 pi fourths. And if you reduce 6 pi fourths, you'll get 3 halves times pi. So starting from 6 pi fourths, the next one is at 7 pi fourths. And then finally 8 pi fourths brings us back to 2 pi, right? 8 pi over 4. At a pi over 4 or 45-degree angle, both x and y were the same. So I'm looking at a triangle here. Let me draw this on paper. At a 45-degree angle, On the circle, x squared plus y squared is 1. Here's the 45-degree angle going through the origin. If I make the right triangle out of that thing, I have a triangle whose hypotenuse has length of 1, and that's the line y is equal to x. So that's the line that has both legs the same length. So if both legs are the same length, then both x and y are the same. So let's just use the letter A to denote those lengths. And with the Pythagorean theorem, then I have that a squared plus a squared is equal to 1. So we have a squared plus a squared is 1, which says 2a squared is 1. Solving for a squared gives me a squared is a half. Take the square root of both sides, and I get a is 1 over the square root of 2. And I hope you recognize that once you rationalize that, that becomes the square root of 2 over 2. That is both the x and the y coordinate at the 45-degree angle. X is square root of 2 over 2, and y is square root of 2 over 2, because the x and the y represent the legs of the table. If I take those two numbers in here, square root of 2 over 2 squared plus the square root of 2 over 2 squared, they will add to 1. That's where they came from. So I want to go back to my diagram of the unit circle and now label that ordered pair and use the symmetry of the circle to label all of the 45-degree angle type jumps with those two ordered pairs with the adjusted plus or minus sign for the quadrant. So here's the 45-degree angle. It's the solid line. So I just discovered that the ordered pairs here were both the same. They're both the square root of 2 divided by 2. At all of the pi over 4s, since that 45 degrees is our reference angle, the ordered pairs are all going to be those except in quadrant 2, x is negative, y is positive. In quadrant 3, x is negative, y is negative. And in quadrant 4, x is positive, y is negative. So let's label all the ordered pairs in that way. So to get to here, I have to go back in the x direction, up in the y direction. So negative square root of 2 over 2, positive square root of 2 over 2. For our pi over 4 in quadrant 3, both x and y are negative. So let's make both of the square root of 2 over 2's negative. And in quadrant 4, x is positive, y is negative. So let's put the x to be a positive square root of 2 over 2 and y to be a negative square root of 2 over 2. Again, in all of these pictures, that radius has a length r, 1. So when we do x over 1 and y over 1, all we have to do is look at the x and y to determine the sine and cosine of that angle. So this says that the sine of pi over 4 and the cosine of pi over 4 are both square root of 2 over 2. This one over here says that the cosine of 3 pi over 4 is negative square root of 2 over 2, but the sine of 3 pi over 4 is positive square root of 2 over 2. Down here at 5 pi over 4, I have that the cosine of 5 pi over 4 is negative square root of 2 over 2. The sine of 5 pi over 4 is also negative square root of 2 over 2. And then finally over here, cosine of 7 pi over 4 is the positive square root of 2 over 2. Sine of 7 pi over 4 is negative square root of 2 over 2. So that's the benefit of working with the circle of radius 1. the members of the ordered pair tell us that x and y are going to be the cosine of the angle that we're talking about and the sine of the angle that we're talking about.
Will they always be the same order, like the x will always be cosine?
Always, always. Remember how we defined it? Cosine was x over r. We're just taking r to be 1 in this picture. So let's go back here and fill in the positive functions and the negative functions. Remember, all students take calculus. So every single one of them are positive here, and none of them are negative. Which two are going to be positive in quadrant 2? Sine and 1 over sine, which is the cosecant. So the sine of the angle and the cosecant of the angle. And the negative ones are all the rest. So that's going to be the cosine, the tangent, the secant, and the cotangent. Those will all be negative there. In quadrant 3, which two are going to be the positive functions? Tangent and cotangent. Tangent of theta and the cotangent of theta. The negative functions are all the rest. The sine and the cosine. 1 over the sine is the cosecant. 1 over the cosine is the secant. Those are the negatives. Which two are positive in quadrant 4? Cosine and its reciprocal, so cosine and secant. The other ones are negative. So sine is going to be negative. Tangent is going to be negative. 1 over the sine is the cosecant. 1 over the tangent is the cotangent. Now the tangent still represents the slopes of the lines, or y divided by x. So if you want to know the tangent of any of these angles, the tangent of pi over 4 is y over x. Well, y and x are the same. So the tangent of pi over 4 is 1, just like the tangent of 45 degrees. Back here, tangent is -1. Tangent of 5 pi over 4 is +1, and tangent of 7 pi over 4 is -1. So once you see the pi over 4, all you have to do is decide what quadrant you're in to decide the plus or minus. All right, so now I need to go back to my paper again. This angle here, the first dotted line you encounter in quadrant 1 corresponds to how many degrees? 30. I'm going to show you that what 30 degrees corresponds to. Suppose I want to convert 30 degrees to radian measure. So I know that 180 degrees is equal to pi radians. So if I start with 30 degrees and I want to end up with radians here, then I need to multiply it by a fraction that has degrees down here and radians up here. So this says that 180 degrees corresponds to pi radians. If I multiply 30 degrees by pi over 180, the degree units cancel and just leave me radian measure. This degree here on top cancels down there, and I have 30 pi over 180 radians. But we can divide 180 by 30. It goes evenly 6 times. So this simplifies to 1 pi over 6 radians. Now, just like 30 degrees is 1/6 of 180 degrees, pi over 6 radians is 1/6 of pi radians. So I'm going to take go back to my unit circle here, put my 30 degrees and my pi 6 radians right here. And what I want you to look at now are all of the dotted lines. All of the dotted lines are separated by 30-degree arcs. That's 30, 60, 90, 120, 150, 180. 180 plus 30 is 210, plus another 30 gives me at 240. 30 more is 270. 30 more is 300. 30 more is 330. 30 more brings me back to 360. So let's write down all of those degree measurements just by adding 30 to the previous measurement. So if this one's 30, 30 plus 30 says this one's 60. 60 plus 30 gives us the 90. 90 plus 30 gives us 120. So we're only looking at the dotted lines now and the quadrantial angles. 120 plus 30 gives me 150. And then 150 plus 30 gives me 180. 180 plus 30 gives me 210. 210 plus 30 gives me 240. 240 plus 30 brings me to 270. 270 plus 30 gives me 300. And 300 plus 30 gives me 330. And then to make a quick check, 30 more brings you back to 360. So those dotted lines are 30 degrees apart from one another. But they divide the top half of the circle into 6 equal pieces. That's 1 6, 2 6, 3 6, 4 6, 5 6, 6 6. Keep counting. This becomes 7 6, 8 6, 9 6, 10 6, 11 6, 12 6. We're going to write those as radians in reduced form. So here's 1 pi over 6. The next one is 2 pi over 6. But what does that reduce to? So let's put a pi over 3 right here. Then 3 pi over 6, do you agree, reduces to pi halves? The next one is 4 pi over 6. Both 4 and 6 are divisible by 2. So this becomes 2 pi thirds. The next one then is 5 pi over 6, and that's not reducible, so we just write 5 pi over 6 here. And then 6 pi over 6 is pi. The next dotted line then, corresponding to 210 degrees, is 7 pi over 6. The next one is 8 pi over 6. So let's reduce the 8 over 6 to 4 pi over 3. 30 degrees more, or another pi over 6. 8 pi over 6 brings me to 9 pi over 6. Both 9 and 6 are divisible by 3. So that's where the 3 pi halves comes from. The next one then is 10 pi over 6. Divide those by 2, and we get 5 pi thirds in this blank. And then finally, 11 pi over 6 is not reducible, so 330 degrees corresponds to 11 pi over 6. 2 pi is 12 pi over 6.
Can you go back to where you converted the 30 degrees to radians?
Yes, I will. Okay. So I set our conversion factor to convert from degrees to radians. To convert from degrees to radians, we multiply by pi radians over 180 degrees. So let's go and confirm what we labeled on the other page by taking 210 degrees, multiply it by pi over 180, and see how many radians that is. And then I'll whip my circle back out. Convert 210 degrees to radians. Take 210 degrees and multiply it by pi radians over 180. I take my 210, there's my degrees, multiply by pi radians over 180 degrees. I write it like that to convince me that the degrees on top cancel with the degrees on the bottom. Then I can knock a 10 out of each of those. And then I notice 21 and 18 are both divisible by 3. 3 times 7 is 21. 3 times 6 is 18. So I can cancel from, let me write that out first. I'm going to cancel 3 out of here, gives me 7. 3 out of here gives me 6. So my claim from this conversion is that 210 degrees corresponds to 7 pi over 6 radians. Yes.
Would you get the same answer if you multiply 210 by any of the radian over its
If you multiply by 2 pi radians over 360, is that what
Yeah.
you're saying? Yeah,
something like that?
I just reduced it to keep from having to carry the 2 and the 360 around. So let's go to our circle and look at what we put in as the radian measure for 210 degrees. 210 degrees is in quadrant 3. So here's 210 degrees, and looky there, 7 pi over 6, just what we calculated. Now, when we develop the X and Y values in our chart for our degree measures, right here, those came from looking at special triangles. I can draw those same special triangles with a value of R and different lengths, but they'll all be similar to triangles with a R of equal to 1. So in other words, the ordered pairs at the 30 degrees should be the same as the sine and cosine here. Remember, the cosine is the X coordinate, the sine is the Y coordinate. So at 30 degrees, my ordered pair on the unit circle should have X is square root of 3 over 2 and Y is a half. So let's put that here at our 30 degree mark. X is the square root of 3 over 2 and Y is a half. At every pi over 6, then I should have the same ordered pairs, but adjust the plus and minus signs. So if I take that ordered pair over to the pi over 6 version in quadrant 2, I keep my Y value positive and I make my X value negative. So the pi over 6 in quadrant 2 is here. I should have a negative square root of 3 over 2, positive 1/2 as the ordered pair. I stuck with the pi over 6s. Pi over 6, keep the same ordered pair, just change the sign on the X. So if I go down in quadrant 3 to the pi over 6, both X and Y are negative. So keep the square root of 3 over 2 and 1/2, but make them both negative. Negative square root of 3 over 2, negative 1/2. Then to the pi over 6 over here in quadrant 4, the 11 pi over 6, X is positive, Y is negative. So this ordered pair is a positive square root of 3 over 2, and Y is a negative 1/2. So far, so good? Okay, 30 degrees and 60 degrees are 90 degrees apart. 90 minus 30 is 60, 90 minus 60 is 30, which says that if I take the cosine of 30 degrees, I get the sine of 60 degrees. In other words, the X's become the Y's and the Y's become the X's. So take that ordered pair now, switch it, and that's the ordered pair for the 60 degrees or the pi over 3. I'm sorry, 60 degrees is pi over 3. So up here, the ordered pair is X is a half, Y is the square root of 3 over 2. That says that the cosine of pi thirds is a half The sine of pi thirds is square root of 3 over 2. But it also tells me now how to fill the remaining blanks. Keep that ordered pair intact. Just make the x and y negative depending on the quadrant. So let's go back here. Which one is negative here? The x. So we got a negative 1/2 positive square root of 3 over 2. In quadrant 3, both are negative. So a negative 1/2 negative square root of 3 over 2. And then in quadrant 4, x is negative. I'm sorry, x is positive, y is negative. X is positive 1/2. Y is a negative square root of 3 over 2. My claim is if you know these 1, 2, 3, 4, 5 ordered pairs, you know them all because of our reference angle stuff. But now instead of counting in degrees, we count in radians. One, two, three. Where did page 1 go? Nope, that's not page 1. There it is. How are you doing so far? Great? I like fantastic. Fantastic is great. So what you probably need to do is do this unit circle a couple of thousand times. I just downloaded it from the web. I put a blank one on Blackboard if you ever need to practice it on your own. But understand the relationship between degrees and radians. So let's take some practice converting degrees to radians. How about we take a, let me think one of the ones that I had on your test here. Let's take 960 degrees and convert it to radians. Convert 960 degrees to radians. I don't want the reference angle just yet. I want the exact measure. So we're going to just take 960 degrees and multiply it by pi divided by 180. So the degrees will cancel, leaving us with radians in the numerator. You can knock out a 0 and you have 96 over 18. I think 6 goes into both of those. And so 6 goes into 96. Let's see, 6 goes into 9 one time, leaving me 36. So that leaves me 16. 6 goes into 18 3 times. So that corresponds to 16 pi over 3. All right, so let's figure out how to draw an angle of measure 16 pi over 3. I want you to think in radians now. All the way around the circle, if I continue in thirds, would be 6 pi thirds, right? So 1 lap around is 6 pi thirds. 2 laps around is 12 pi thirds. 3 laps around is how much? 18 pi thirds. So I've gone too far. I've gone 2/3 too far. So if the bottom half of my circle represents 6 sixes, I have to go back 2/3 of those. So do you agree that that's in quadrant 3? So let me do that again. We're going to draw that angle. So this is 0 radians or 2 pi radians, and this is pi radians. So that's 1 pi. Let me divide 3 into 16 and write that as a mixed fraction. 3 times 5 is 15 with 1 left over. So that's the same as 5 1/3 pi. So I'm going to use that and the fact that half of a circle is pi radians. So that's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And now I need to go 2/3 of the way back. 1/3 puts me in here, 2/3 puts me in here. So that's going to be in quadrant 4. In quadrant 4. At the pi thirds, I would need to know the which pi thirds is in quadrant 4. Well, if I write this in thirds, that's 6 pi thirds. So my reference angle here is going to be a pi thirds. Right? I'm pi thirds away from the next axis. At the pi over 3 is how many degrees? 60 degrees. Do you know the ordered pair? What's the cosine of 60 degrees? And what's the sine of 60 degrees? And this one is in quadrant 4, so it's negative. So we just discovered that the cosine of 16 pi over 3 is a half, and the sine of 16 pi over 3 is negative square root of 3 over 2. One nice thing about working in radian measure is that denominator of our reduced fraction tells us what our reference angle is. 16 pi thirds is in reduced form, so I know that my reference angle is pi thirds. Yes, sir.
I thought you said it was in 1/3.
It's 2/3 of the way. Oh, it's 1/3.
Yes, 1/3.
Silly, I went 2/3. Yep, you're right. Caught me. Caught me. It's 1/3 of the way. That's 2/3 of the way. So we got to put it back here in quadrant 3. Do I get partial credit? I don't need it. I have my degree. 2 degrees. Maybe 2 2/3 of a degree. So let's take that back. 16 pi thirds is back in here. So the ordered pair is the same, but both of them are negative. So let's make the cosine of 16 pi thirds a negative number. But the idea is, in the reduced form, the denominator tells me what my reference angle is. So if I want to know, say, the sine or cosine of 21 pi over 4. Well, 21 over 4 is reduced, so I know my pi over 4 is my reference angle. So sine or cosine of 21 pi over 4 has the square root of 2 over 2 in it. Next, I just have to worry about what quadrant 21 pi over 4 is in. Would anybody like to take a guess in which quadrant we have an angle of measure 21 pi over 4? Write that as a mixed fraction. 4 goes into 21 how many times? So I'm 5 1/4. 5 laps takes me back to pi, right? Or 5 laps. 5 pi is back here. 6 pi is over here. Positive x-axis is 6 pi. Negative x-axis is 5 pi. So again, this feller is going to be in quadrant 3. So it's a little bit easier to find where the angle is. Just think of your circle, pi, 2 pi, 3 pi, 4 pi, and so on. Okay? All right, we'll pick it up from there next time. If you have any questions on whether I graded your test properly or not, I'll be here for a few seconds. Few seconds. Everybody good? I'm gonna shut this guy off.
You got T minus 10 seconds.
So